Now let's look into the one architecture of neural network, one method from neural network, autoencoders. So autoencoders are a type of neural network architecture used for unsupervised learning and dimensionality reduction. They are widely used in various applications, including image compression, anomaly detection, and feature learning. So let's have a detailed explanation of autoencoders. But here we'll have a overall rough understanding about the autoencoders. When we get into the neural networks, that time we'll be working on that in depth. Okay, so let's begin with a definition and explanation. Autoencoders are a type of neural network designed to encode the input data into a lower dimensional representation and then decode it back to the original data format. The purpose of autoencoders is to learn an efficient representation of the data, often called the latent space or code, with minimizing the reconstruction error between the original input and the decoded output. So the key idea is to learn a compressed representation of the data, capturing its most important features. Then, history of encoders. Autoencoders were first introduced in the 1980s as a neural network architecture for unsupervised learning. They have gained popularity in recent years with the advancement of deep learning techniques and their successful applications in various domains. So now let's look into some of the assumptions under this. Autoencoders assume that the input data has a meaningful lower dimensional representation and that the most important features can be captured by learning a compressed representation. So they are effective when the input data exhibits patterns and structure that can be exploited to create a meaningful code. So then let's see some of the applicability of some of the applications and use cases of the autoencoders. Autoencoders are applicable to various types of data, including numerical data, images, text, and other types of sequential data. So they are used in tasks such as image and audio compression, anomaly detection in data, feature learning, denoising data, and data generation. So now let's look into the mathematical aspect of autoencoders. The mathematical formulation of autoencoders depends on the specific architecture used. The most common type of autoencoder is the feed-forward neural network with an encoder and a decoder. Let's denote the input data as X and the output reconstructed data as X dash. The encoder function is denoted as f of x and the decoder function as g of f of x. The objective of training the autoencoder is to minimize the reconstruction loss, typically measured using a loss function like mean squared error or binary cross entropy. So now let's look into the algorithm working process. The working process of an autoencoder involves fundamentally three steps. The first one is input data X is fed into the encoder, which maps it to a lower dimensional representation f of x in the latent space. 2. The latent representation is then fed into the decoder, which maps it back to the original data space, resulting in the reconstructed data x dash. 3. The reconstruction error is computed by comparing x and x dash, and the model is trying to minimize this error through backpropagation and optimization algorithms like stochastic gradient descent (SGD) or ADAM. So this is what about the autoencoders. Now let's see some of the activities that can be done through autoencoders. Image compression. Autoencoders are used to compress images into a lower dimensional representation, which can be useful for efficient storage and transmission. Then anomaly detection. Autoencoders can be trained on normal data and used to detect anomalies or outliers in new data based on the reconstruction error. And the feature learning. Autoencoders can be used to learn meaningful representations of data that can be used as a features for a downstream task like classification and data generation. So variational autoencoders, a variant of autoencoders can be used to generate new data samples similar to the training data. So overall, autoencoders are a powerful tool for unsupervised learning and dimensionality reduction, and they have shown significant success in various real-world applications across different domains. But this belongs to neural network. Let's wait for that time. So once we get into the neural network, we'll be deep diving into the auto encoders.